I really enjoy working with high-power electronic circuits, especially sine wave inverters and DC-DC converters. Part of the reason is that these products sell quite well in my country, which helps me pay my monthly bills. My next project is one of those designs, a voltage regulator that can operate from 90 volts to 265 volts and deliver a stable 220 volts output. And that's where the problem comes in. I need a 12-volt power supply that can handle sudden input voltage fluctuations and still provide enough power for the MOSFET gate drivers and the cooling fan. Most power supply modules on the market either can't meet these requirements, or they're too bulky, or simply too expensive. So in this video, I'll be building a wide input range power supply module that meets all the technical requirements of my project. Let's get started. Thank you to JLCPCB for generously sponsoring the PCBs for this project. In the past, I usually made PCBs by hand, which meant I could only build small single-layer boards. That really limited creativity. You had to keep projects simple enough to make at home. Now, with JLCPCB, those limitations are gone. I can freely design 2-layer or even 4-layer PCBs at a very low cost with excellent quality. JLCPCB is currently offering huge promotions on their 6-layer PCB projects. Sign up now to receive discount coupons worth up to hundreds of dollars and enjoy PCB and PCBA services from one of the world's largest PCB manufacturers. You should also regularly visit JLCPCB's Facebook page. They share plenty of useful information and fun mini-games for you to explore. Very quickly, I received my PCB. This power supply module uses quite a lot of SMD components. If you decide to use my design, I strongly recommend using JLCPCB's PCBA service. It will save you a lot of manufacturing time and help you avoid the toxic solder fumes that come with hand soldering SMD components. Since this is only a test version, I'll hand solder it before placing a large quantity order. Using a D16 soldering tip is a good choice for these components. After finishing the SMD soldering, we move on to the through-hole components. My design uses relatively few external components, but it still includes all the basic protection features, and the output ripple remains within an acceptable range. This design uses an EE19 transformer with a 0.5mm air gap. It has only 2 windings, the primary and the secondary, with 75 and 15 turns respectively. In theory, this transformer can easily deliver an output voltage from 12 to 15 volts with a maximum current of 1.5 amps, which is more than enough for my projects. The main controller IC is the TNY290PG. This IC integrates a power MOSFET internally and does not require an auxiliary startup winding, making it very suitable for wide input range power supply designs. This is the circuit after all the components have been soldered. I noticed that the module starts operating at an input voltage of just 13 volts. Of course, at such a low voltage, the output current is only a few tens of milliamps. I was genuinely surprised that it could start up at such a low voltage. With an input voltage of 110 volt DC, this module can easily power 5 cooling fans, delivering an output current of approximately 1 amps without any issues.